Welcome. Today we'll learn how to find dy slash dx using implicit differentiation for the equation y sine of x squared equals x sine of y squared. Let's solve this step by step. First, let's recall that when we differentiate implicitly, we need to use the product rule and chain rule, and remember that y is a function of x. Let's start with the left side. We need to differentiate y times sine of x squared. Using the product rule, this gives us dy slash dx times sine of x squared, plus y times the derivative of sine of x squared. For the second term, we need to use the chain rule. The derivative of sine is cosine, and we multiply by the derivative of the inner function, which is 2x. Now for the right side, we need to differentiate x times sine of y squared. Again, using the product rule, this gives us sine of y squared plus x times the derivative of sine of y squared. For the second term, we need to use the chain rule again. The derivative of sine is cosine, and we multiply by the derivative of y squared, which is 2y times dy slash dx. Now we can set up our equation. The derivative of the left side equals the derivative of the right side. Let's solve for dy slash dx. First, let's move all terms with dy slash dx to the left side and all other terms to the right side. Now we can factor out dy slash dx from the left side. Finally, we can solve for dy slash dx by dividing both sides by the factor in brackets. And there we have it. We've found dy slash dx using implicit differentiation. The key was carefully applying the product rule and chain rule while remembering that y is a function of x. Thank you for watching.